Now see this problem. A ball is suspended by a thread of length L at point O. Here it is, a ball is suspended by the thread at point O, and there is a wall. Now this should be the mean position of the ball, and it's pulled. The thread is pulled, that it is ball is now at this extreme position, making an angle beta with the vertical line, and then released. And by the way, the wall makes an angle alpha with this vertical line. Now this alpha is less than beta, and it's set free. So considering perfectly elastic collision between the ball and the wall, find the time period of this motion. So as you know, it will not be a complete SHM. Okay. So we can frame an equation of this. Say this theta, angular displacement, equal to angular amplitude beta sine of omega t, that's root over g by L times t. This may be the equation of the SHM. Maybe means if you take this as a this as time t equal to 0 when the particle is at the mean position and moving towards the right, and consider theta this way, angular displacement this way. So this, see, from here to here, here to here, and back to this point, this is half oscillation, right? Now this part is half oscillation. Achha. And from mean position to this angle alpha, it is not half oscillation, it's less than half oscillation. So we'll find out the time taken for the displacement from mean position as alpha, say theta equal to 0 to alpha, maybe on this side or that side, doesn't matter. So we can substitute here alpha equal to theta sine of root over g by L t. So therefore the time to reach this, alpha is beta, sorry it's beta. Okay, I mean we have substituted theta as alpha, so beta sine root over, so t is equal to root over L by g sine inverse alpha by beta. So therefore the total time period of this motion is, see, it's pi root over L by g plus, see, this t is this time, right, time to go from here to here, so that has to be multiplied by 2, so 2 root over L by g sine inverse alpha by beta. Okay. Right. Let's move on to the next problem. Find the time period of oscillation of the block if given a small displacement in the x direction. So this is the x direction. Okay. And it's given that block and springs are on smooth floor. Now if this is displaced by x, now let's draw another diagram, a rough diagram here. This is the block here. If the block is displaced by x, it is small displacement, each of this angle is theta. So this spring is compressed by x cos theta, and this spring also, it is compressed by x cos theta. Now let's look at the forces acting. And what about this spring? This spring gets stretched by x only. Okay, so these two springs will push the rod. This force will be k1 times x cos theta, and this force also k1 times x cos theta, each of this make angle theta, and this force equal to k2x. So now again you have to consider these components. Okay. So each of this is equal to k1x cos square theta. So we can write the restoring force F equal to minus k2 minus of k2x plus 2k1x cos square theta. So k2 plus 2k1 cos square theta multiplied by x. Therefore, the time period is 2 pi root over of mass m divided by this k2 plus 2k1 cos square theta. Now let's move on to this problem. A pendulum is constructed as a light thin walled sphere of radius r. Again, C was given in the problem, filled with water and suspended at point O from a light rod. Here, distance between O and center of the sphere is L. So I have to mark this center of the sphere to this point O is equal to L. Right. Find the time period of simple harmonic motion. Also, what will be the time period if the water freezes? So, well, here, as this rod oscillates, so let this angular displacement be by theta. Angular displacement be by theta. So, total energy of the rod, of the system, not the rod, total energy of system is, I can write E equal to, okay. Now, what is the velocity of this center of mass? So that is L d theta dt. That means theta dot, right? Theta dot is d theta by dt. So it's L theta dot. So this is the velocity. So the rod is massless and also the mass of the shell is also neglected. So if for potential energy, if you take this as a reference, then potential energy is minus mg L cos theta. For kinetic energy it is half m v square, that is L theta naught. So L naught theta dot square. Okay. Now it involves only the translational kinetic energy. Translational kinetic energy. Why? As the water does not rotate, simple as that, the water does not rotate. That means the level of water. So water, suppose there is a small gap and this is the level of water when it was straight, and when it goes here up, water will maintain its own level. So the orientation of the water does not change. Okay, so E is this one, minus mgl cos theta plus half m, this is translational kinetic energy. So now we can differentiate it with respect to time. D by dt equal to 0 implies 0 equal to this is mgl sin theta dot, that means d theta dt, that plus half m l square. Now 2 theta dot, theta double dot. Okay, so therefore theta double dot will be, this 2 will cancel, theta double dot will be minus, see as it is small angle, sin theta will be theta, so minus g by L times theta. So the angular frequency is root over of G by L. So time period is 2 pi root over of L by G. Now, question is just what will happen if this thing, if it freezes, right? If it freezes, then water will, if water freezes, it will have also rotational kinetic energy along with the translational kinetic energy. So that's ice, and when ice goes here, the orientation of the ice changes. I mean, that is, say on the ice, if you consider a line here, so this line will also rotate. So total energy equal to, so same for the potential energy is same. So it's minus mg L cos of theta plus half mvc, this translational kinetic energy. So velocity is L theta dot. So half m L theta dot square plus kinetic energy. So sorry, this is translational kinetic energy. For the rotational kinetic energy, you have half 2 by 5 m r square multiplied by the angular speed is this theta dot square. So in this way, if you do this d by dt equal to 0, you can find out the time period. So you'll get such a term, no? Theta naught, theta double dot is minus omega square into theta. You can calculate it easily. So we'll move on to the next problem. Yeah, see here. A uniform solid cylinder of mass m performs small oscillations due to two springs. If there is no slipping between cylinder and ground, find the time period of oscillation. So there is no slipping here. Here there is no slipping, so you can write kinetic. First we'll displace it and then write total energy of the system, which includes kinetic for the disk and potential energy for the springs. So suppose I consider here, if this goes by x, center of the disk goes by x, so the velocity of the disk will be v, total energy E is half mv square plus half into half m r square into v by r square plus 2 into half k 2x square, right? Okay, so now therefore E is equal to half mv square plus 1/4 mv square plus 4k x square. Differentiate E with respect to time, you get 0, equal to half m 2v dv dt is a plus again 1/4 m 2v again dv dt a plus 8k x dx dt is v. Okay, so yeah, you have a equal to minus kx by m by 2 plus m by 4 times x. So this is omega square. You simplify then and get